Hi everyone, I'm James, and it's an honor to be here today. I've been asked to discuss bee data on iNaturalist, which is a topic that I've been examining together with this awesome team of collaborators listed and pictured here. Now, as you know, monitoring bees involves coordinated efforts among trained collectors and institutions that have capacity to handle large volumes of specimens and taxonomic experts who can tell you what you caught. This effort requires a large amount of time and money. And when any of these things is lacking, we get gaps in our knowledge. So we need all the help we can to collect more data. And this is why community science platforms like iNaturalist are such a boon to us. For those who don't know, iNaturalist is a community science platform that allows anyone to take a photo of an organism in the wild, upload it, and anyone in the world who knows the identity of the organism can contribute an identification. The platform then keeps a database of all the observations that have been uploaded to it and their history of identifications. Since the launching of this platform, an army of over 250,000 users have submitted bee data all over the world, totaling nearly 1.8 million records as of when I'm making this recording. This means that there are almost 2 million data points that members of the naturalist community have offered up that we don't have to go out and collect on our own. And besides the sheer volume, there are some other great qualities about this data set that makes it very desirable. For example, iNaturalist makes it very easy for people to upload data with the correct collection information just by setting the date and time correctly on their phones or digital cameras, and either enabling their device's GPS tagging functions or roughly remembering where they were when they photographed the organism, which means that there is minimal lag in the data entry process. It also does a great job at capturing ecological interaction information in the field in the form of just the photo you took, allowing anyone to collect plant data without a plant press or bringing a botanist friend into the field. It also is non-destructive, which means that the bee is able to keep doing its thing instead of taking up space in your museum drawer. Also, since the data are born digital, the identification process also happens in real time, from the initial ID to the subsequent revisions. So in this example, this cute gal was initially uploaded simply as a bee, and then a community member identified it as a Sphecodes, and then experts weighed in with a correction, and finally, the authoritative alpha taxonomist provided a species level ID. This whole process happens in a very transparent way, and the database is instantaneously updated for every record that gets corrected or upgraded, which is something that's very difficult to achieve with specimen data. Now, some of you might be skeptical and have some questions about the validity of using iNaturalist data for serious science. You might have questions like, can you actually identify bees from just photos? Aren't people just photographing the common and charismatic megafauna like Apis and Bombus? Won't there only be data where there are lots of people walking around with smartphones? Do the data actually tell us anything that we don't already know from formally collected specimens? And what if I don't trust the people doing the IDs? These are all valid concerns, and I'll give some perspective on each of them very briefly today. First, significant portions of iNaturalist records across the world are identified to species, in large part thanks to a relatively small handful of ultra-fanatic identifiers who really know what they're doing. And if you're not particularly impressed by their ability to identify bees to species, based on what I'm showing here, I think it's at least commendable that they have been able to get the vast majority of uploaded specimens identified to the genus level, and often to the subgenus level. And from here, we can start to do some very coarse level functional trait analyses and have a pretty good handle on what bees are occurring in which regions. Moving on to the second question, the answer is yes, honeybees and bumblebees and carpenters take up 8 of the top 10 most observed bees on iNaturalist in North America. But I think it's important to note that these species altogether make up only 45% of all records, which is actually a pretty equitable rank abundance curve, if you ask me. As comparison, my own dissertation data set, the top 10 bee species accounted for 60% of all the specimens. Next, regarding the issue of biases, spatially speaking, we see that the iNaturalist dataset of wild bees do in fact reflect overall human settlement patterns. But despite that, they cover approximately 3/4 of the grid cells shown here, including some pretty rural areas. And having a concentration around urban centers isn't necessarily a bad thing either, because that's some of the places where human activities have the largest impact on bees anyway. So that's where we really want to be tracking what's happening to our bees. And when we look at how these data stack up against publicly available digitized physical specimen records, like the kind you get from GBIF or SCAN, we found that iNaturalist contributes a huge portion of the total wild bee data coming in the last 20 years. This is in part driven by an actual dearth of physical sampling, but it also reflects significant delays associated with the specimen processing, identification, and digitization process. In contrast, since iNaturalist data are born digital and updated in real time, the time lag there is a lot less severe. This means that if you want to see what's happening to bees in real time, you really want iNaturalist data to fill in the gaps for you. And even when we look past the raw abundances and consider the species level, we found that for over 750 bee species, iNaturalist provided the only publicly available contemporary data over the last 20 years at some localities, and this kind of phenomenon occurred in the vast majority of the grid cells that we examined on this map. This shows that iNaturalist is capturing significant amounts of unique bee occurrences that inform the contemporary status and distribution of our bees, at least for the subset of the species that can be reliably identified from photographs. All right, lastly, the 200-pound gorilla in the room. What if you don't trust the iNaturalist data, since anyone out there can provide an ID? Well, this is definitely a problem that takes a village to solve, in my opinion. And the more of us bee nerds can spend time on iNaturalist identifying records, the better. One thing I want to point out is that the research grade designation on iNaturalist is neither necessary nor sufficient to validate the accuracy of these IDs. So here's an example of a record that spent some time as a misdetermined research grade record, and then some more time as a record that is correctly determined by the taxonomic authority, but not designated research grade. But having said that, because of how thoroughly the ultra-fanatic bee nerds are checking the iNaturalist bee records all over the world, my sense is that the majority of both research grade and non-research grade records are actually quite trustworthy for the most part. And if you're doing any analyses where it's critical that all of your data have to be correct, you always have the option of doing your own due diligence. And one way to do that is to throw the points on a map and look for obvious outliers. So for example, when you map Asian honeybee records, you can be pretty sure that the records in Europe and the Americas are incorrect data points. And then you can go back to your data set, click on the URL for each of these flagged records, and then check them and correct the errors on iNaturalist itself so that any future user wouldn't have to do that same step to correct the data. And if you're not super confident in your own identification skills, you can collate these fishy data and have a taxonomic expert look at them. So if you would take a tray of physical bee specimens that you're not so sure about and send them to a taxonomist to verify, I think there's no reason that we shouldn't embrace that same kind of practice for our digital specimens as well. All right, so that was a pretty brisk walk through what my collaborators and I have been thinking about. Hopefully, we've convinced you to seriously considering leveraging the power of iNaturalist datasets and to consider contributing to it by being an observer, an identifier, or both. And finally, as a parting thought, if you're here today, you have likely filled out the registration form and had to ponder the issue of crediting those who contribute to your ability to use digitized data. Since iNaturalist data are mostly just a slurry of distinct data points, there's no means to credit the observers and identifiers by citing an academic publication. So you will have to take some extra steps to figure out how you would like to include them in your scholarly product. And hopefully we'll all walk away from this RCN meeting with a better idea of how to do that. With that, I would like to thank the 130,000 users who have submitted observations and the 16,000 users who have made identifications of North American bees, especially the folks who have identified a disproportionate number of records, 2 of whom have been working with me on the work that I just presented. And of course, thank you for being here, and I look forward to our discussion. Bye-bye.